Hey all, so in this chapter we're going to run into radicals, which are these things, in the course of solving quadratics. And so sometimes we'll have nice ones where they're perfect squares and they simplify really easily. And then we're going to have some other ones where they're not perfect squares and we're going to have to do a little bit more to get those into simplified forms for our answers. So reminder what a square root means. A square root means what I'm looking for the number that when multiplied by itself would make 16. So what times what would make 16? 4. So the square root of 16 is 4. Another way of looking at that is if we have the square root of 4 squared, which is what 16 is, the square root is undoing the squared, and what we're getting is the 4. So a square root basically asks, it actually is asking if I have a square of area 16, how long is the side? 4 by 4. But so that's what we're saying is what times what would make 16, 4. So that's our perfect squares. So if we had the square root of 25, it would be 5. The square root of 36 would be 6, etc. And when we get into simplifying these ones that are a little bit harder, which is to say they're not perfect squares, the numbers we want to look for are these perfect squares. And it could be 7 squares, 49, 64, 81. But we want to look and see if I can divide any of these numbers into the number I'm using. So here's why. So with 12, 4 goes into 12 3 times. So 12 is 4 times 3. There's a property of roots that says if I have root a times root b, I can write that as root a times b under the radical, or vice versa. So if I have this, I can write it this way. If I have this, I can write it that way. And what I have right now is this. I'm going to write it this way. So this would be the square root of 4 times root 3. Square root of 4 makes 2 root 3. And so that's how you simplify a radical, is you're trying to get the number under the radical to be as small as possible by simplifying out any perfect squares. So that's the easiest way I can see to do these. Some videos might write this as 2 times 2 times 3, and then for every pair of 2's, one comes out front. That's another way of saying the same thing. For me, I just kind of look for what can I divide into 12 that's a perfect square. 4 is it, 4 times 3, so square root of 4 brings out a 2, leaves behind the 3. If I was trying to do square root of 150, does 4 go in? Nope. 9, I don't think goes in. 16, not. That doesn't look good either. 25 goes in, right? So, and the other thing is we want the biggest perfect square, so sometimes 4 can go into a number and maybe 16 can go into the number. You always want the biggest one. So with this, we would say 25 goes into 150 6 times. So I would think of that as 25 times 6. And then square root of 25 brings a 5 out front, and it leaves behind the root 6. When I write these, I always put the perfect square first, just to make it easier for me to not write something backwards. So I'm realizing I'm taking the root of the square, that's what's coming out, and then the other number staying behind. So that is how you simplify radicals.